Hey everyone, this is Will. Welcome to the 8th intro miniKanren hangout. No, advanced miniKanren hangouts. Something like that. I was gone the last 2 weeks, but I'm back and I'm excited to see Evan talk about his debugger for miniKanren. And I also have a few thoughts and questions about a possible improvement to Barliman, which is basically a type of super autocomplete that combines semantic autocomplete with syntactic autocomplete, that kind of thing. So I can talk about that for a few minutes. All right, no further ado, on to you, Evan.
All right, so I have my Smalltalk image here, and I thought that I would start out by making a couple of clarifications for what the Smalltalk syntax means, both because I use that to write the miniKanren programs, obviously, so those can be interpreted, and I reuse the conventions in printing out the representations of various internals of the search. So it's pretty simple. Colon equals is just variable assignment, and so if I highlight this, do it, then A has a value of 1, right? Nothing too fancy there. Curly braces, delimited by periods, is an array syntax. So this gives us an array. And square brackets is basically a lambda or a block where the arguments are colon, prefixed variable names, and then this vertical bar separates the parameters from the function bodies. This is just, lambda xy, x plus y. So that's the kind of the basic data type primitives that will be needed here. Oh, and prefixing something with a hash is a symbol.
So Evan, what does C look like if once you've assigned to C, what does C print as? Just okay. It's
source code representation type thing, which will be important later because I make use of this to just kind of default print some suspended things. So then there's the last, the second thing is message sending. There's 3 different kinds of message sending, which are all fairly intuitive. If it's an alphanumeric message, then you do object, space, and just the message name. And I should say lines are also delimited by periods in case that wasn't clear. But object, space, alphanumeric message name, and that does, sends that message to that object. So, 1 squared is obviously 1. If it is made of non-alphanumeric symbols, then it is implicitly a binary message between, one object and whatever's on the right, and that does what you'd expect. And if it is an alphanumeric with a colon after it, then it is a variable, sort of a multi-argument method. So that can be 1 argument, as in this case, which is B is an array. So this is array indexing. The element at 1 is 1. Or it can be multiple words with colons, which all collectively build up the same method call on the object C. And value is the way that you call blocks. So this will be sending 1 and 2 to the C adding function and giving us 3 as a result of adding. Does that all make sense?
Makes sense to me.
All right. And then the last thing, which will be important to know about, particularly for this debugger, is inspecting. And this is sort of a function of what the Smalltalk environment is that if you send the inspect message to any object, you will get this kind of window that is a sort of a default interface to that object where you can look at all of its internal state. You can kind of inspect its class hierarchy. You can send it arbitrary messages like we saw earlier and sort of write arbitrary code in this window that uses where this object is bound to self. And so the object can define special methods that get picked up and added as extra tabs. So array has this little listing tab where you can look at the items in it and kind of click on them to expand them in this kind of Mac Finder style interface. And so this kind of gives you a sort of a easy way to prototype very simple kinds of interfaces to objects, which is what my kind of Mark 1 debugger consists of right now, which is just I didn't really write an independent, graphical interface for it. I just added some string printing and added a couple of windows that kind of display in a slightly more interactive way some of its internals. And I do a lot of the interface with just sort of, writing live code in this window, and gave it a few methods to facilitate that. So that's kind of what you're going to see.
Okay. So, can you, in that inspector, can you directly change the values within that array?
Yeah. Yeah, I could do self-et to put 4. And then when I look at this array, 4.
Cool.
I can send it any method as though it were any part of the code, right? It's just kind of totally arbitrary. Assuming it is a mutable object, obviously. So with that, I'm going to go to my window full of simple miniKanren programs, or SmallKanren, I guess, is my port to Smalltalk with miniKanren. So what we're seeing here is we have I'm reusing block syntax as fresh by basically building a block with some number of arguments, and then I send it, this as goal to convert it to a miniKanren goal, which basically just looks at the number of arguments, creates all the fresh variables, and kind of sets up the reified goal that way. And then I'm calling runner on the goal, which is just kind of my default object that has all of the current state of the search, and you use it to step through the various elements of the search, right? And so this is going to be a fresh variable x. This is unification, and this is just the constant 42. And so if I inspect that runner, I can see the source code of sort of the current, I'm calling source just like a textual representation of the current state of the search tree. And so this is the way to read this, and this is going to be probably a little bit cryptic just because I've been kind of adding, symbols to represent things as needed. But this outer layer of square brackets I'm using to represent a delayed goal, and that delayed goal has this literal print of the block source code that it has not yet executed. Make sense?
Yep.
And so now I can go back, and obviously I could sort of arbitrarily look at the internals of this, but I've given the runner this step function, the step method, that you can use to open up a runner on the next iteration of the search tree. And in this case, you can see here we've gotten rid of the outer layer of brackets, and now this is just a delayed goal where instead of x equals 42, it's actually processed the source code of x into a variable, which it's given the unique identifier 0, and it's saying this is a unification of the 0 variable in 42. And
wait. So that's before the unification has taken place?
Yes, this is a delay on top of the unification, right? So
okay. So it's a single equal instead of 3 equals at that point?
Yeah, I guess I just used a single equal there. Probably should be triple equals, but there are a couple of things here that probably don't print in the most obvious way, just because it's kind of accumulated some history. But yeah, that's just I just happen to add a single equals in the printing code somewhere, wherever that is. But yeah, but that's a unification goal between now and actual variable instead of this suspended code it hasn't evaluated yet.
Okay.
If I step again, I get, and this is, don't worry about this, this is just means it's a state, and I kind of gave state a printing that means there's one bound variable in the state, and it gives us a list of the bound variables, except that it's an empty list because it only prints variables with debugging tags on them, which is something else I'm not going to get into right now. So since I didn't actually add any debugging tags, it doesn't print any literal things, but it does tell me that there is one bound, and I can use this tab to see that the 0 variable is bound to 42 in the state that I've returned. And then one more step gets me to an infinite, empty list because I ran out of steps. Everything makes sense so far?
I think you got me until this last set of things. I think I got a little lost.
Alrighty, so I advanced the unification goal, which succeeded and returned this sort of state. I'm calling it a state. It's a fully complete answer to return to the user, whatever the appropriate terminology for that is, right? With a fully, all of the substitution has everything, it satisfies all the goals it's returning.
Okay, so is this like your reified substitution or constraint store?
Yeah, so the state contains the substitution and the constraint store and whatever else. It's the whole pack. It's a package.
Okay.
I think it's called in some of the papers, right?
Maybe I'm having trouble reading this thing. So I'm getting confused with all the stuff on the upper left-hand pane. So you're seeing a stream, but then there's a package. So are you looking at the value of the stream? Are you forcing the stream?
So this is just gonna, I think there's probably gonna be a couple of terminology issues here. So I'm looking at, this is the interface here is generated by what I'm calling a runner, which is just kind of my, object that holds the current search tree and like some debug information and stuff like that. The stream is the current search tree. So this could be like an M+ that's suspended with some incompletes and whatever else in there.
Okay, so I guess I see two different streams. I see a stream on the left, and are these two different time steps in the two windows? Is that what I'm saying, left and right? Oh,
yes,
okay.
This is the first one, and I stepped here, and this window popped up with the next iteration of the tree, the next bounce of the trampoline.
Oh, okay. So you're not inspecting part of the left; it's the different time.
No.
Okay, that's where you're confused.
And then that second one, the unification advances into a it actually does the unification and returns the substitution with the unification stuff. And since there are no more goals, this is just the part of the stream processor where it just returns, I think you have like the variable A in the paper where it just kind of returns A because there's no other streams to process.
Okay, so I have a feature request, I guess, which is, could you display the timestamp also, or the step
number?
Yeah, so you could see somehow that, like if you didn't know the step number, you wouldn't necessarily know that the one on the right is further than the one on the left or the next step or whatever, I guess.
Sure. Yeah, you could put the step number. So what's kind of going on here is that so the runner has a step method that returns itself stepped one time step, right?
Okay.
And if I just ran this and printed it, I would get, it doesn't have an interesting print, it's just a runner, right? And so I know kind of, because this is how the Smalltalk interface works, that if I print it and if I execute it and go, it'll open up the result of this in the next window here. So I think this is a kind of function of, if you're evaluating this, this scrolling action isn't actually like a default thing. I'm literally using the default Smalltalk scrolling interface and using it to inspect this lined up array of, this doesn't have to be the next time step. I could like inspect the number 3 here and I would get an in-depth analysis of the number 3, right?
Gotcha.
So, but yeah, so this is, I could open this in a new window. I could kind of do all of that.
All right, I guess part of it is when you're actually running it, I think you have a really good sense of the context, and it's a little harder for me to tell, not knowing Smalltalk as well.
Right.
Okay.
Yeah.
Cool.
That's definitely I kind of assumed there would be some kind of communication hurdles to overcome in terms of I'm interacting with this, and it's not always obvious exactly what I'm doing here. But yeah. So anyway, at least the overall concept seems to be clear now, I think. So moving on to this one, I have here a conjunction of two unifications, right? So I have a fresh with x, y, and conjunction here is just this curly bracket array syntax with the period elimination between two unifications, x unified with 42 and y unified with 100, right?
Yep.
So it's just like, two adjacent elements in a fresh. If I open this inspector, then I've got my unevaluated source code. I step into the next pane, the next iteration of the search. And this is, it evaluated it, and now it has a delay around. And then the way that I've sort of printed this is that ampersands that line up on one level of indent are kind of the multiple levels of a conjoined goal of some kind. In this case, it conjoins our unification and our unification, and obviously x has gotten a 0 and y has gotten a 1 debug print. That makes sense?
Yes. I'm trying to understand the spacing. So on the second line, there seems to be a space between the ampersand and the left bracket. Is that something? Is that supposed to indicate anything, or is that just kind of how it printed out?
I think it's doing a very tiny tab.
Okay.
Yeah, no, but these kind of, yeah. See, there's the tab. Good. These are on the same conceptual line, even if it didn't quite print that way on the pixels.
Okay, but is there supposed to be an extra space then after that ampersand?
I mean, there's a tab, I think.
Okay. Okay. So they're supposed to be aligned though, basically, right?
Yeah, the ampersands are conceptually aligned, and the thing after them are just and this is just kind of me trying to like fit this whole tree structure into an ASCII printout that made some kind of sense. So it's not necessarily the most intuitive thing in the world, but it kind of is more or less consistent, assuming there are no bugs. It's just that ampersands in a row are all the same kind of node of the tree, and these are the sort of the children of it. That makes sense.
Okay. Okay.
And then step through this again, and I have a state which has now done both those unifications, as you can see.
Oh, I think I missed it. All right, so can you run that one again from scratch? Let me make sure.
Whole thing?
Yeah, let me make sure I understand
Okay.
what's going on.
So starting with this delay on an unevaluated source code goal.
Okay.
We step once. Now to compare the sources, we have evaluated this outer goal, and then this second square bracket is a source code block. Now this outer thing is a delay again, and the delay is over this sort of now actual miniKanren goal that is basically a fresh or conjunction of something equals 2 and something equals 3.
Okay. All right. And then when you step it again, are you getting the final answer, or are you going to try to evaluate the first unification and then the second unification?
Oh, so these steps are at the level of, I think that we will run both of those conjoined goals at once.
Okay. Okay. All right. Okay, so why did you pick this particular level of granularity? Or I'm not sure I understand the level of granularity. So when you're stepping, what are you stepping between? Like which states do you step between?
Mm-hmm. Let me think. I would have to step through it to remember, because I wrote this a while ago, exactly what choice I made. But it's, it's generally supposed to be kind of, let's see. Yeah, I'm not sure I can remember exactly how to frame that in context here, because I don't remember exactly what the alternatives were.
Okay. Well, one thing I noticed in this program, there are no choice points or decisions, right? You're not making a disjunction, so you may as well just run it. I guess if you had a choice, then you might want to stop at the choice and explore the two different options. Right. So maybe we'll see that in a minute.
It should do that. Okay. Yeah, what I can't remember is whether I explicitly decided to run everything at once, or whether that just kind of happened implicitly and I didn't even kind of have to consider. And I don't remember exactly what the construction process was.
Okay.
But anyway, so you can see also that in the final returned answer here, we have 1, which corresponds to this, the unified to 100, and 0 unified to 42.
Gotcha. Would it be hard to allow stepping through the individual unifications?
No. In fact, that's kind of implicit in the fact that I'm sort of writing arbitrary code in this interface. So I can, for example, I can use this step, which is really just a convenience to kind of bounce me between these things. But I could also, instead of executing step, debug step. That brings up a debugger, which I can kind of arbitrarily, get down into every step of the unification, through everything I've written, right?
Not sure I understand that.
So the step jumps between kind of individual bounces of the tree, right? But it doesn't step between one recursive call of walk and the next recursive call of walk, literally through every instruction, right?
Sure, sure.
And so instead of just running step and viewing the response, I highlight step and do debug, that will open up a whole different window that is just the debugger, which I can use to step through every individual instruction. And so now you can see here I'm kind of getting into the unification where I can I'm walking variables and I'm defining, and I can go as far down as I want with that.
So if you want to do something in between those granularities, like you just want to do each unification, like full unification by itself without getting into walks and that kind of thing, could you kind of easily wrap that around this debug code?
I would have to take a look at how I have it set up, but basically what you would want to do is something like add another method to the runner, and then instead of step has some whatever level of granularity you're talking about, and then just have it run whatever you want and return a runner with that. I don't specifically have a sense of what you have in mind, but it would there's nothing this is at a sufficient level of generality that you would just kind of program whatever it was you wanted and give it an appropriate display, and that may be easier or harder depending on what exactly you want to do and how I have it set up. But
okay, so the use case I have in mind is say you had 20 unifications in a conjunction. My understanding right now is that they would all happen at once, but if say it failed and you'd want to kind of maybe step through it to figure out exactly where the failure happened, I was wondering, how hard would it be? I mean, this is also maybe a question of the Smalltalk stuff rather than just the debugger. How easy would it be to sort of cons up a version of the interpreter that could do it at the level of each, call it equal, instead of the entire conjunction?
Yeah, no, okay, I see what you're saying. I don't think it would be too hard. I would, I obviously I couldn't say without kind of going to look at it and trying to think about how to do it, but in principle, you would just sort of take a look at the conjunction. A conjoined goal is its own kind of object with a kind of a method, and you would either you would either want to define some kind of well-defined representation of that intermediate state, and be able to view that, or I mean, depending on your needs and familiarity with the framework, you could just kind of halt at the appropriate place inside the code and just throw a debug in there. But yeah, I mean, definitely doable. I don't know without kind of trying to design it how easily doable, but
okay.
Makes sense.
Yeah, because I can imagine even more sophisticated things like, here's a conjunction, and if it fails, I want you to bring me up to the point where it fails.
Yeah, I can see that. I will say that part of my need for something like that hasn't kind of cropped up, partly due to the fact that the source code representation does a lot of filling in of what the current values of variables are, as I think will be seen later. And so I can usually just kind of eyeball why something will fail because I see something is supposed to equal something else, but it doesn't. So it's
okay.
But yeah, I mean, depending, one could kind of go arbitrarily far in that direction, I think, and maybe maybe that will be something to explore if I start needing that to write more complicated things or whatever. But it's not something that I have already implemented.
Okay.
Anyway, so moving on to the next example. This is a disjunction, which I've represented as an array that contains another array. And so any secondary array in one array is treated as a condi, kind of like how you would write it in normal miniKanren scheme. And what this one, you will start to see kind of more of the interesting behavior of the choice points, which is that, and this is kind of really what starts to make this useful for, because it gets hard, with this text representation is very limited when you start having a giant program deep somewhere into the interpreter, the relational interpreter, where you have tons of different suspended things. You just kind of have no way to make sense of all of this data. And so one of the things that I've been doing so I'll get there in a second. So similar with the ampersand, this double bar is my kind of, Conde goal that hasn't yet been turned into an M plus yet, with the delay over a Conde goal with those appropriate unifications. I step that. Then I have these pluses that I'm using where each plus is one branch of an M plus, right? And so everything, given a line of M pluses, those are all kind of part of the same part of the tree, and everything to the right of that M plus or with a level of indent is that branch. Does that make sense?
Okay, so these are two different Conde clauses metaphorically.
Right, so we've evaluated the Conde, we got the M plus that built up the kind of, search tree, which in kind of miniKanren proper is like a bunch of lambdas. Here I have it reified as an M plus so I can display the contents and stuff. In one branch we're evaluating something equal, x equals 100, and one branch we're evaluating x equals 42, right? And the zeros are part of my neural net learning stuff, where I'm, will ideally at some point give each branch a value and they will sort themselves by priority. But right now I'm not actually using that, so it just kind of prints a bunch of zeros. And what you'll notice here, so I could step.
So are you talking about the zeros to the right of the plus, or the zeros inside of the variable? Okay, that zero.
Yeah.
Okay.
This is an M plus with priority 0, but they're all priority 0 unless they have an answer, in which case they're priority 1. That's just my default kind of.
Okay.
Yeah, so those don't do anything interesting yet, but eventually they'll be like floats and they'll sort themselves appropriately or do something like that, hopefully. So I could keep running this as per the sort of normal execution, right? And I'll get, an answer and, another delayed goal or something like this. Or I can go back in time, as it were, and take a look at the individual branches. And this interface lets me pick some branch and just continue as though none of the other branches existed, so I can explore what happens down that choice point.
Oh, nice.
Right, so this is what lets me kind of run the interpreter and say, I'm not too concerned how many lambdas it's stacking on like that branch. I want to see what list is doing right now. And I can walk down the path of choices that would get me to whatever list thing I think should be working and isn't, and inspect that along the way, which is kind of how I make it useful for complicated things.
Now, is there a way to see the current substitution or the current constraint store? Because at any given time you're going to be within the context of some package or constraint store, right?
Right. Yes, there is. There are a couple of things on that. Let me use, I think one of these others will make it clearer, right? So here I have a conjunction conjoined, or a unification conjoined with a Conde, right? So I will actually have, I'll evaluate this and I'll have some actual package to worry about, and then I'll be in that context for doing this, which is what you're asking about. Right?
That's right. So when you unify x and y, x will already be 42.
Right. So a couple of things there. So I start out normally. I got that goal. Anything interesting has happened yet? And I should say next jumps to like the next answer. So you can skip a few answers instead of doing every bounce of the tree, but I haven't needed to use that. That makes sense. Next is jumps to what you would do when you were actually running miniKanren, the next actual thing you would return. It kind of jumps up to that point. So you can take larger steps through the space.
So that's a bigger step than step.
Yeah, let me demo that real quick, I guess. So
okay. So is that running to completion?
It runs to completion of one answer.
Okay, gotcha. All right. So step is going to go to the next choice point, I guess, and next will get you the next answer.
Step is kind of like the next, bounce of the tree where it kind of sorts, resorts the tree, right? So if you have like a bunch of delayed goals, step will step through each delayed goal in turn.
Okay.
If I had like a bunch of recursive calls right on top of each other for some reason, or a bunch of calls to functions to freshes that get suspended, right?
Okay.
So, but next we'll just kind of cut through all of those and get to the next completed state.
So for step, is it like you have a work list of delayed goals and you're gonna force all of them one step?
I don't. So basically, what step is doing is, so you know how in the kind of the standard stream code for miniKanren, you kind of keep stepping, you keep evaluating the function until you get something that has like a list with like something in front of it, right?
Yeah.
So next is equivalent to that, where you keep evaluating the function until you have a list. Step is just one evaluation of that function.
Okay.
Whatever that
turns
out to be.
So when you say get an answer back from next, that's not necessarily a final reified answer. It's more like the stream has produced, something other than a delayed goal or a failure. Is that right?
Answer. It is produced something other than a delayed goal or an or a. I guess let's see. What would be the terminological bridge here? It is produced. Next jumps to the point where you have a list of a package consed with like possibly an infinite stream.
Okay, so this is like the top level stream, so you actually will get a reified answer back.
Right.
Okay.
The step just evaluates the infinite stream, kind of one step, whatever that turns into. Like maybe that just, like if you have a bunch of condies stacked up, it'll just like flip the tree around, but not do anything too interesting with that, and just kind of keep on jumping there.
So if I understand correctly, then if you call next, it could go into an infinite loop. But if you call step, it's not going to diverge unless there was a divergence in scheme, like calling omega in scheme or something.
Right.
Or the equivalent.
Yes. Step. Yeah. Step. You can call step as often as you want, and it just does one bounce and comes back. But next, we'll go looking for that goal.
Okay.
For that goal. Yeah.
All right.
So,
I think I've got a better sense of what those do then.
Sure. Okay. Yeah, it's kind of hard because, like, particularly, I've realized when I've been watching all of you like working on the scheme code, I'm like, I understand this in principle, but since I'm not working on this actual like setup and I have a very different thing, it's like this kind of sometimes tricky to figure out what corresponds to what, like what part of my code am I looking at here and stuff. But it should be all it's all like roughly the same shape. Anyway, we have, let's see, so we got the conjunction, we evaluate the conjunction. Yeah, so now we're in this kind of choice point here. And so if we were picking, I guess, so I guess I didn't add one to this, although I could. Yeah, so I'll note to self, I'll add that later. But assuming we were picking one of these, then we would see what our reification is currently in the context of this goal we haven't yet evaluated, right? So we see that variable 0 is bound to 42, and we're unifying variable 1 to 100. Does that make sense? So we got a condi here, and we got two possibilities. We're either unifying 0 with 100 or 0 with 42. But we've already, remember from the code, we've already run x equals 42. Now we're doing y equals this or y equals this. So this unification has already put something in the substitution, right?
Yeah, I understand that part. I guess I'm having trouble following the interface because okay, so there's the representation of the condi. Yeah, okay, so what's the difference between the thing on the left and the thing on the right? So the thing on the left is the original program source code, is that right?
The thing on the left is this is a delayed goal, and this is a goal a condi goal that has not yet run. It hasn't received a state. It hasn't like created a stream. It's just a goal constructor.
Okay, and then you go inside the. Okay, so
yeah.
So the thing on the right then has the +0, so that's the weighting.
Right. So this is the actual stream that was produced by this condi. That's why.
And then I think
that's why I use double bars here and pluses here, and I realize it's kind of like cryptic to people who haven't been working on it, and that's just kind of I kind of figured that was something I was just going to have to deal with because I couldn't think of anything better that was I could easily implement in ASCII. But
but then I thought I saw another screen which looked similar but without the +0s.
This one.
Yeah. So what's the difference between that and the previous screen?
So this source is always a string representation of the entire thing,
Okay.
Branches is a list interface that I can use to actually like select one, and it will continue going.
Okay.
Yeah. So this is much like how with arrays. Where's my array? Yeah. Arrays, you have this items thing that lets you kind of highlight and pick items, which is something that array like specially implements. And then you could just have, if array doesn't have this, but you could just have one that's like result of self as string, and it would just like have that string right there that you couldn't actually like navigate or anything. It's just a string. So that's what we have here, where source is just a string representation of the whole thing. I can't really interact with this except to like copy parts of it or something. Branches is each of those branches gets a list item that I can click on to dive into.
Okay, so if we look at the first one,
source.
Oh, sorry, the branches. If you look at the first branch,
mm-hmm.
Okay, and what is the 1 = 100 then on the right?
1 = 100 is the y variable, which got turned to 1, unified with the number 100 as a goal. A delayed unification.
Okay, so can you go back to the original source code? I guess, yeah, I'm confused again. So, all right. So we had x is 42. There's no choice point there, and then we have a choice point between y is unified with x and y unified with 100. Okay, so can we go back to what we had?
And you'll notice that instead of x here, it filled in the value of x, which is what I was talking about earlier. And ideally,
okay, so the second one is x to y, the unifying of y and x. Is that the second choice point? Okay, but it's in the opposite order than the code. Is that?
I guess so. Yeah, I don't know. That's just how how my condies run. Apparently, I don't know.
Okay, all right. Now I think I got it. Yeah. Okay.
Yeah.
So
but yeah. So ideally, I would have like some symbol here that's like x is like a tag for the variable here, and I have that for some parts of it, but that's just kind of a to-do item that would make it clearer, but I haven't done yet. That's saying like this is the number 42. This is literally like x bound to 42 that I've reified and added here for clarity, right? But this is also kind of this principle here is what makes it possible to kind of navigate the code, because it sort of fills in a lot of the values here, so you can kind of see if you saw like 32 = 42, you're like, oh, two variables that are supposed to unify have decided to take on values that clearly don't unify. So like that's why it will fail here. That's why I haven't. That's what I was saying earlier when like it kind of makes it somewhat clear why some of the unifications fail, even if you don't step through them exactly.
Okay, I thought I understood, and now I definitely don't. Okay, so can we go back to the original source code? All right, so we have x gets unified with 42, and then either y gets unified with x, which would be y being unified with 42, or y gets unified with 100.
Right.
Okay, all right. So maybe I'm understanding sort of. Okay, so if we go back then, so the 0 in brackets is y. Oh wait, cool. It's changed on me now. Okay, so on the left-hand pane, the 0 in brackets is x, and the 1 in brackets is y, right?
I don't think that should be happening, but I think it. Oh, I see. Huh. I forgot to appropriately tweak my branches display to reflect what the. Yeah, I think it's just kind of coming up with a new variable scheme because I just hacked this in.
Okay. Okay. All right. Okay, I guess the numbers were throwing me off a little bit.
Yeah, okay, that makes sense. Yeah, so these should be.
All right, so then when we step it, and so we're looking at the case of y being unified with 100, for example. That's in the context of x being 42. So how do we see that context?
So I could, I forgot to add a like current state to the condi, or the sort of the m+ thing, but we can see that if we dive into that goal. So this is if we've chosen that branch, right, where this is the branch where y is being set to 100.
Yeah.
We have this reification tab that tells us the current bindings of all of the other variables.
Okay.
So we can see that 0 here is 42, even though it doesn't show up in the code at all.
Gotcha. Is there some way to keep the original identifier there?
Yes. So I just haven't implemented it for this. So what I can do is if I don't use my kind of fresh notation and I just like made a variable, x equals variable new or whatever, I can add a tag that's like, x or something like this.
I see. Okay.
X will start showing up like with a kind of a special X annotation instead of 0, or rather I think it'll be like X0 so that you can have multiple X's in case it recurses on something you've named X.
Sure.
And that's something that I am kind of have part of the way through adding the ability to do for these fresh ones. I just haven't gotten to it, but ideally you'd be able to like add like a tag to the skull that says debug, and it'll like have it insert these variable names into the tags of these variables so that the debugs all show up more clearly. That's just kind of another to-do item that hasn't come up as a top priority lately.
Okay.
But yeah, that's definitely a thing. Okay, any other questions on this goal?
I think I finally understand it. Thank you.
Perfect. And so the last one is constraints. I have 3 constraints implemented. The symbolo, or for a lot of these things I just kind of reuse the most Smalltalk seeming for various reasons. So this is symbol is kind of how you check if something's a symbol, and I just reused it for creating a symbol constraint, which has the nice property that if you pass in a grounded symbol instead of X, it'll just reify to false, and then false will create an always fail goal, and it'll just kind of kill that without actually bothering with the constraint system.
Wait, sorry, I missed that part.
So I've created so this is a fresh, right, kind of standard, and X, Y, and Z are therefore unbound variables, and I'm saying X is symbol, that message creates a symbol constraint, right?
Yep.
What I'm saying is that is symbol is also, is also the kind of the default way in Smalltalk to check if a thing is actually a symbol.
Okay.
Outside of, and so if you pass in a ground value here, it will actually just, instead of making a constraint, it will evaluate to true or false, and true or false will turn into, when the kind of goal system collects them, either an always succeed or an always fail goal. So it's just kind of like a shortcut if your variables are ground to not bother with some computation.
Okay, cool. And the Smalltalk symbols, they begin with a colon?
They begin with a hash.
A hash, okay. Okay. Okay, cool.
Yeah, the colon is just for like variable arguments and blocks. It's its own little thing.
Okay.
But yeah, so there's that. This is the disequality, y is not equal to 1. And I've used excludes here instead of absento, just because Smalltalk has includes, but strangely not excludes. So I just kind of went with the theme.
Okay.
It also has a lot of very odd names for things based entirely on Arlo Guthrie's Alice's Restaurant song, as I understand. This is the horse you want to be hitching your carriage to, but there it is.
Is that true?
Oh yeah, so you're familiar with Alice's Restaurant?
Oh yeah, I'm very familiar with that.
You know the part where he's like, I was like, injected, inspected, whatever.
Yeah.
So I think Dan Ingalls, if I recall correctly, decided that they were going to use that for all their higher order. You can have like array, and instead of filter, you have select. Instead of map, you have collect. Instead of kind of fold, you have inject. And there's like a few others. Inspect. Yeah, I think there's a couple more that I'm just checking on. But yeah. So that was kind of weird at first, but anything because you get anything. So anyway, this is just a conjunction of all 3 constraints, just to kind of put them all on the map at the same time. And what
so
is that and reification is just like always there, even if it's empty, just because this is kind of a hack, and I didn't doesn't bother me, so I left it alone. But just because it was easy, because I already had 2 different objects representing empty and non-empty constraint stores, I went ahead and made it so that constraints only shows up if there are constraints. And you can check here and see that 1 has this disequality constraint, 0 is a symbol constraint, and 2 has an excludes 3 constraint.
Okay, and if you run step, does that run all 3 constraints at once? I mean, does the conjunction run, because there's no choice point, does it run all of them?
Yeah. It just yeah. So this was our our goal that we haven't evaluated yet, and this is a finished state where it just kind of ran through all the goals and put all the constraints in the store.
Oh, so can we look at the finished state again?
This is the finished state. There's like this kind of cryptic.
Okay, that okay, I see. All right.
And this is the nicer display of that.
Cool. All right.
Yeah, state for whatever reason I think just kind of. I never added something that suppresses the constraint output. So if you have a bunch of constraints, it just kind of blows up and gets harder. Gotcha. That's why you have this list.
Cool.
Yeah. And so that's really it. I kind of added this isn't really something to follow, more as just kind of like, in principle, you just sort of like a proof of concept, right? And so like, because even I when I'm going through this, I have to like think about my code and like what. This is the relational interpreter, and so you can kind of start stepping through that, and it kind of starts to get, complicated, and more stepping, and then you have like branches, and you can say, well, let's see here, I've got, this is quote right here, the quote branch. I've got my, what is this? This is the lookup branch, and I've got the list branch, just because I only have those 3 operations, and so I can say, okay, I want to go see what lookup is doing, and then I can look at those reifications and keep stepping on in there. So yeah, so this is not really point of this is not really to follow exactly the flow of the relational interpreter, just to kind of get a sense of what this looks like in a more like non-trivial size program. Is that you can, thanks to the branch selection stuff, you can kind of keep it simple enough to start following a thread of execution as it accumulates constraints and as the source code starts to unfold. If that makes sense.
So is your interpreter fast enough to generate the non-trivial quine?
Well, I haven't, in this particular iteration, I haven't implemented apply and lambda. So I've just been working with these 3 to get things running. So okay. I haven't put it to that test yet.
Okay. I'm just curious that, one of the things I still don't really understand is why, sort of why we are able to generate that non-trivial quine relatively quickly.
Why you or aren't?
Why we are able to.
Mm-hmm.
In other words, there's like actually a fair amount of pruning going on in the search tree.
What the branch towards it kind of looks like.
Yeah, I don't have a very good mental model, or I'm sure I have a terrible mental model of what's actually happening.
Well, I will.
And so
I will see
that's sort of that's like my use case, right? Like if we can figure out, get insight as to why the quine generation is actually relatively efficient.
Mm-hmm.
My hope is that will give us both a better understanding of what's going on, and maybe give us some ideas of other problems or techniques that are useful, and also it would be a good way maybe to drive what you'd want in visualization of the search tree, because it's still a fair number of steps to get that quine.
Right, and yeah, so yeah, that's definitely something I can kind of try to explore with this once I implement those last few things, which will be probably in the near future, and see if anything interesting pops up. One thing I will kind of add on here as a sort of a note that I've been kind of wondering about and this is almost this, somewhere between debugging and like performance analysis, since we're kind of talking somewhere between those at the moment. So for the learning stuff, I've got let's here. Yeah, so this is just kind of me diving into the internals, and so I've got this. Guess I'm not accumulating it here, or what's going on? Oh, I think it's still, yeah. So since I haven't actually done kind of any unifications, it hasn't done anything interesting yet. It's still kind of built up on the stack, but I have this path here that's accumulating basically a kind of what I believe is a sort of a history of my path through the tree. What I've been kind of wondering about is if you can kind of like collect a bunch of those and do some kind of like analysis about which branches of the tree it's like spending a lot of time in, or like some way to like visualize or measure. I don't quite know how that would work yet, but that's been something I've been kind of musing on. So rather than in addition to kind of being able to step through it, being able to like run it a bunch and kind of try to ask like what, where has it, gone into a branch that spends a lot of time in and never done anything or something like that. I don't know. But yeah, so I will see if that turns into anything. But anyway, that is the extent of my debugger Mark 1, as it were. And I will probably return to it once I get some of the neural net stuff working and have to actually figure out why it isn't working, because it inevitably will not on the first try.
So what sort of uses have you had for the debugger so far?
So it's been really helpful in debugging so I would kind of, redid a lot of the internal stuff of miniKanren. And as I, to kind of set it up for, getting the learning stuff in place and like writing the relational interpreter and stuff like that. And it's been really useful for that because like, since I can, especially for these simple cases, I can so easily step down a branch and see why the interpreter is not returning anything because I, gave it a cons instead of like a proper list or something like that, or, like any of these sorts of things. It's been really useful to be able to kind of actually like build and debug in the kind of most direct sense the relational interpreter. And also because I can sort of break out that debugger and step into the unification, I've been able to like debug my constraint framework and my unification and stuff right in the middle of that. So it's been kind of like very handy as like a kind of a straightforward, I want to step through my miniKanren program and figure out why it fails here and why it returns nothing or why it returns this or something like that, because I can see that unfolding in a few clicks rather than like, a lot of, before I had this, I could use the normal debugger, but it was like a long way down with all of the kind of, bouncing and twisting around and delaying and stuff like that to even find the code I was looking at. And then when you get there, you're never really sure because you don't quite know what state the package is in, or like if you're in the right branch because it's all bouncing around and everything. So like being able to walk down nested condies and know which branch I'm in and what the values are has been very handy to getting miniKanren programs up and running.
Yeah. Have you seen? Okay. So I guess one question I have is, given that this is written in Smalltalk, is there, any sort of equivalent tooling we might imagine having in Scheme, or is it, is it the sort of thing where it's like, well, if you want to debug it, you should debug it in Smalltalk, and if you want to run it and make it super fast, you should run it in Shay, or do we have to live in two worlds, or is there, are there insights here that we can transfer over?
So I think I have a couple of thoughts on that. Just depending on where the kind of constellation of other miniKanren implementations is at any given point. One obvious thing is just sort of like writing a Scheme reader and then using Smalltalk miniKanren as a kind of debugging program, a third-party kind of debugging program, which would obviously require like at least a minimal amount of Smalltalk to kind of know what the interface does and like how to send messages to control it. Yeah. But given that one has that kind of basic level of understanding, you could kind of potentially have enough of an analog between them to see it perform. Although obviously, if you're then going to go change your miniKanren implementation to do something crazy like delayed goals or something that isn't the way that this is currently working, then you might be out of luck for that. But another possibility is that a lot of what is done here is really, particularly since all of the schemes are going to have their kind of their REPL environments that you can work in live. A lot of what makes this possible is really just that instead of writing in terms of a bunch of different lambdas and then evaluating their results, like the infinite stream code, this system, and there's like a bunch of kind of deprecated classes to ignore here, but this system reifies kind of all of the possibilities in the normal miniKanren scheme code. So like there's, an M plus class, an empty stream class, a single delayed class, the kind of, actually I don't think that's one to use, a bind class with a goal waiting for a goal suspended above another stream. So like if one were to write a miniKanren where instead of using the kind of Lambda stuff, you reified those as record types, then I would imagine you could do something very much like this, where it, well, I mean, this is kind of, speaking from a very, very high level above this. I would have to like really, think a lot more about exactly what it would take. But I would have to imagine that you could probably achieve something, which isn't very specific. But yeah, I guess I don't know.
Well, I know at one point Michael Ballantyne had an explicit, data structural representation of the search tree when he was working on different versions of the search. And the sense I got was that made it a lot easier to see what was going on.
Yeah, because so more things. So think about it now. I think a lot of what you need is being able to like get the state out of what is otherwise just like a closure you can't really access, right? And so when you reify it and you have like the current state of each suspended piece, and you can actually walk the tree instead of just having like an opaque closure, so you can actually graph, like chart down what the current state of the search is, then yeah, you should be able to make a couple of pretty printing widgets and just kind of use the REPL to kind of hack something like this together. I think it would, the more I think about it now, the more I think that it would definitely work as long as you reify the different choices made by the stream code that currently package everything as lambdas. Because you need to be able to walk, like the tree of M pluses, right? Which, in miniKanren is just a lambda. You need to be able to walk down that and get the choices so you can choose which branch to go visit next, right?
Yeah.
And that's a lot of what makes this useful for non-trivial programs, is being able to choose a path rather than, just having to like click step 1,000 times while like an enormous search tree does its thing, right?
Sure.
But yeah, I think it should be doable.
Okay, cool. Yeah, well, certainly our debugging in standard miniKanren is pretty pathetic. It's like fail, you get back the empty list or an infinite loop, and that's it.
Yeah.
It's like good luck. The thing we've done in the past is we've used project to try to print out some of the contents of the substitution, and that's it. But of course,
Yeah. I think the only trick is just it took a little bit of thinking to figure out exactly what the different cases were, since they all just kind of use this sort of uniform like lambda incomplete interface. So like sorting it out into the single suspended thing, the M plus case, the bind case, and I have a few other cases that I think are not in this package just because of shuffling things around. But yeah, figuring out what the actual case decomposition is of that stream code and reifying it, I think, is enough to do pretty arbitrary debugging stuff to great effect, I might add.
I also wonder, visualization-wise, I don't know if this would be useful, but it does seem like it would be at least potentially useful to be able to see the entire visualized tree as a, as actual displayed tree where you could click on the nodes, right?
Right. Yeah, no, I definitely had that thought as well. I think I showed you a long time ago, like a very loose prototype of a previous version of that no longer works because I've changed everything. So I've thought about trying that again as well. Just sort of, again, kind of is on my things to do later list. What I will say though is that you need to be careful because the visualization can quickly explode to the point where you have something that's either uselessly large and possibly very slow to draw.
Yeah. I think that's always the problem, right? It's like, oh, you really want to see all the data? Okay.
No, you don't want to see all the data, which is why clicking, a click-based interface to like walk down that path, and so that's really like the use case that I can imagine where you click on some Condy, you have like some tree, obviously, some visualization of like a bunch of Condy clauses. You click on one, and then it doesn't simply, like this one just sort of dives into that. But you could imagine like the original tree stays there and like the other branches are grayed out, and you can actually like visualize the whole history of the path you took and walk back up it and see the evolution of a single computation. Maybe would be a useful thing for like a visualized version of this.
Yeah.
But you definitely don't want to like visualize the entire tree after it's been running for like a minute and a half or something, because that's just, unless it's like in a very tight loop, potentially very, very large and not helpful. Another thing that would be nice to do would be kind of like, searching through the tree and figuring out some kind of interface or syntax to like find the places where this variable unifies to that, but like exactly what the interface looks like is kind of a tough question. I thought a little bit about it, but nothing good occurred to me.
Yeah, or the other thing that you often want are like the equivalent of breakpoints in a debugger or things like that. Like what would that mean? I'm not sure. Or maybe you want to go down a subtree and you say like, okay, stop as soon as you hit a failure. Stop as soon as you produce an answer or whatever it is. Like, maybe you want to have that level of control.
Yeah, that's true. Yeah, I could definitely see like kind of a greater level of the ability to kind of like steer, query, and direct the search from some sort of interface is definitely a kind of a future vision that I think is eminently doable if you can kind of solve the interface question.
Yeah, or you might have something like, I don't want to see the entire subtree. Just show me the deepest path before failure.
Right.
How deep can it get before it,
Sure.
Ultimately fails. So, yeah. But once again, until you actually play around with these tools, it's hard to tell how useful they're going to be.
Yeah. No, I think the one thing I kind of came out of this that makes everything worth it is that like choosing the Condy instead of having to like walk through every possible permutation of Condys, that makes it a very useful tool versus a kind of not that useful tool.
Okay, can you elaborate on that a little bit?
Just what I was talking about, like, just the added interface ability to, halt at a Condy, pick a path, and continue down that path without having to like walk through all the other Condys. Because that's what made it so hard. That's what made it so hard to debug this with just the standard debugger, right? So like, Smalltalk has very good debugging, and when I obviously was first writing this and didn't have any kind of sense of what the interface should be, and was just using the kind of standard step through stuff, it was tough because you never knew when you entered a unification what branch of the search tree you were unifying, because they all kind of look alike, right? There's like a bunch of different branches with all these different permutations of what's bound to what. It's hard to keep track of like which, am I in list now? Am I in lookup? Am I in lookup one level down? Like what am I even looking at right here? So like being able to just control that from the beginning and say, I'm going to go through like 2 loops of list and then into lookup or something like that and see what's going on there. That's like the biggest multiplier for debugging miniKanren as an interface concept that I've found. Yeah,
I can see that, because otherwise you just get overwhelmed.
Yeah, and you just can't. You're stepping like forever in this debugger as it like goes all the way down this one branch. You discover that wasn't the branch you were interested in, and then it like goes back up, and the whole tree shifts down. You're not sure where the branch is anymore because they've all shuffled together, and it's no longer the third branch. It's like nested 2 down and then to the right or something.
Yeah.
But yeah, so yeah, reifying those the stream code and then having some kind of interface to halt and choose Condys would, I think, be the biggest thing to do for debugger for Scheme miniKanren from what I've found so far as like an interface paradigm.
So what were those 2? So one is to be able to go down just one choice point.
Reifying the stream code so that you can actually,
Oh yeah, okay. To make it a data structure.
Give you some ability to actually walk through it in some way and like get the state out and stuff like that, get the package, and then the ability to pick, some just easy function to like when you step down to a giant search tree of like a bunch of things m+ together, picking which branch you actually want to follow in some intelligent way, like listing all the branches out that are nested down the tree and then picking branch number 5 and pulling that out of it and continuing down that branch is like so that you don't get overwhelmed by all the different branches that you don't care about that are like building up.
Yeah.
Yeah, I expect if one were interested, one could pretty easily make those two changes and get a scheme-based debugger.
All right, well, that's good. We'll have to add it to the...
Yeah, and if anyone decides that they want to try something like that, I can try to come help figure out how to do it.
Oh, sweet. Well, for anyone watching who's looking for a good miniKanren project. All right, well, thank you. That's really cool.
Alrighty.
I'm curious to see where that goes. Oh, you know, do you think, I mean, I think we've talked about this a little bit. Would a Smalltalk Barliman make sense?
Oh, like, you know, as in synthesizing Smalltalk.
Well,
just like in Smalltalk.
Well, okay, that's one way to go. I was thinking more from an interface standpoint of having something like Barliman, but in Smalltalk.
Oh, yes,
You know,
so that you can, yeah. I mean, so I've obviously, I conflate a little bit Barliman as an interface and Barliman as a relational interpreter synthesis kind of function. So I've got my kind of, you know, simple version of a not yet quite complete relational interpreter, and haven't obviously checked the speed stuff on it yet, and we'll know more once I do. But I think based on that, it would potentially be interesting, you know, because first of all, you know, it's kind of, you know, it's a lot easier to work with a lot of the graphical interface elements in Smalltalk than it sometimes is in like kind of getting out one of the heavy duty graphics sort of toolkits in another language, just because, you know, things are all kind of built to work with the programs and stuff like this. I've also kind of further wondered about something like, and yeah, so this is like a very open-ended kind of question, right? Because there's a number of different things one could do with like a relational interpreter of this type in a Smalltalk environment. What I've been kind of wondering about is, so kind of writing your own IDE is sort of like a hello world for the Smalltalk graphics toolkit, you know, because it's like a, you know, the basic development environment is a very simple composition of like, you know, a text window and a list of classes. And Smalltalk, you know, is one line of code away from listing all its classes and looking up all their methods and changing and compiling methods and stuff like that. So there are a lot of tools that make use of that and do things like linking together test cases to the IDE and kind of linking everything together because it's all sort of like reified and right there. And so one thing I've been wondering about is, you know, because I've been sort of, I was saying earlier, I think offline, trying to think about, well, what would it really take for me to actually use this stuff for my programming? And so I've been wondering about, okay, well, you know, I don't want to necessarily worry about, you know, thinking about how to synthesize like an object system and a class system and stuff like that right now. But given that, you know, a lot of my code in Smalltalk is basically kind of, you know, functional scheme because I have my linked list and I do a lot of things with it. And that's kind of a good chunk of the methods I write. I was wondering about if I could basically say, okay, well, I'm not going to synthesize arbitrary Smalltalk, but I am going to synthesize like, you know, Smalltalk restricted to like a handful of functions on my list and like numbers and things like that. And then just try to like actually build the kind of IDE that I use to do normal coding that integrates the sort of the synthesis stuff into it somehow and like see what kind of permutation of that might actually be useful. And so I don't have like a very clear, concise vision of it yet, but it's something that I'm very much thinking about trying to like, how can I put a Barliman type thing on the actual IDE critical path of my Smalltalk coding? If I just say it's just going to do whatever can be done with lists, numbers, symbols, or whatever like that, and kind of integrate it into the whole like testing coding workflow. So I definitely have some thoughts about that, but nothing conclusive at this point.
Well, I think that's a good point that you brought up offline, which was based on this Alan Kay, thought that if you're building some tool, you should first of all build it to use it yourself, and secondly, you should build it to have 100 people use it.
Right.
And I think we've achieved that with miniKanren, but we definitely haven't achieved that with Barliman. And this is what I'm more thinking about these days is, I'm still thinking, of course, about how to make synthesis faster and more capable and stuff like that. But the other thing I'm really thinking about is what could we build now in terms of IDE that would be useful. And my feeling is that even if we ignored the synthesis aspects completely, we could probably build an IDE for at least a subset of Scheme that had some really interesting features that traditional IDEs don't have. And I would like to get to the point where I can start using that and at least support the language that, say, we implement miniKanren in. So can we use this special interface to edit the miniKanren code itself?
Right.
Or something like that. And miniKanren code is not faster MK's more complicated and longer, but like imagine editing microKanren code, right? That's like 50 lines or something, and most of the code's pretty simple. So if we could even get to the point where we could start editing microKanren code in an IDE that had these special features, I think that we would learn a lot from doing that.
Yeah, I think so. Yeah, no, it was definitely like, to the extent that this is supposed to be something that like makes programming easier, it is a kind of like an open question about like, well, why doesn't it make it easier for me yet? Like what is it that's holding me back exactly? And there's like obviously some issues of speed, like an infinitely fast thing that could just write any program would be great, but like there's also, just trying to figure out what exactly my programming habits consist of that this could fit into, right? Because like I don't generally find myself needing to like download a third-party application to write append for me. So like, what is it that I do need it to do, and how do I make it do that? Something I'm thinking a lot about it, but I don't have any very good answers yet. But I feel like it should be able to do something. I have an intuition, but.
Well, so the suspicion I have is that at least in the near future, the synthesis part is kind of a distraction and a red herring. And that now the cool thing about writing the interpreter in a relational way is that we have a bunch of other capabilities that are also unusual, that are indistinguishable from the miniKanren side with synthesis. Like, okay, we get synthesis for free in some sense, for some value of free, but synthesis is expensive. It's exponential. You can run into infinite loops potentially, or whatever. Or maybe you just don't find the answer.
Right.
So that still remains a hard problem, and no one in the world can really do recursive program synthesis, basically worth a damn. And I mean no one. For general recursive programs, right? There's some very specialized cases where you can do something, but. So that's just beyond the current state of the art. We want to move the state of the art forward, but that's that's like a decade-long, or 15-year, or 20-year, or 30-year project, right? That's not a we're going to have that next week. So what is it that we can have, if not next week, next month, or in 6 months, or something like that? And I think the one thing that we can have are using the using the features of the relational interpreter to do kind of the other things we show in Barliman. Like, the first thing we always show in the Barliman demo is synthesizing something like append or, map or something like that. But I think the more interesting case, or more useful case right now, is the fact that you can write down tests, and then as you're using Barliman as an IDE, just as an editor, it'll immediately tell you if one of the tests can't be satisfied, even though you still have holes in your program, right? And that is something that's like, well, why don't I have that in my current IDEs? That's something like where now I'm kind of upset. So that's one thing. And then the other thing, it would be, so I gave this, I gave a demo of Barliman at HARC last last, not this past Friday, but the Friday before, which I told you about. And, Sean McDermott made the point, which was well taken, that, Barliman is not very interactive. In other words, like, it either works and synthesizes your program, or it fails and gives you no information. But it's like, you just kind of have to set it up, and you're sort of setting up this computation, and then you're like hoping that it does something, right? It's not giving you as a programmer any feedback as you're actually writing the code if you're using Barliman as an IDE, right? And so I've been thinking about that. I mean, obviously he was not the first person to point this out, but that was sort of the the push. It's like, all right, well, let's take this seriously, right? And also with working with the folks at Cornell on the educational version of Barliman, Galadriel, which hopefully they'll do a hangout on with us at some point soon. I want to see what sort of support we could have in that version, with Molly and Yiting and the other students working on this. One thing I think would be very interesting would be basically a super autocomplete. So this is something I also think we could build today for at least the limited subset of language we're handling. Okay, so what's keeping us back? Let's take a step back. What's keeping us back? They're holding us back from using it. So one is, I don't actually think it's primarily speed at this point. I don't think speed's for synthesis, sure, speed's a problem, but I don't really think that's the biggest problem. If you're trying to run tests to see if they pass or fail, for example, at least it's not clear to me speed's the problem. It could always be faster, but I think what is one problem is expressiveness. Like, we don't handle arithmetic. Right, that just cuts out certain types of programs that you can write right away, and so part of this may be, well, we have to just go back and do some engineering effort and integrate the constraint, basically the finite domain constraints, right, to give us at least some ability to do arithmetic over integers. And to be honest, most of the scheme code I write does not use floating point numbers at all. It's like all arithmetic over natural numbers. So that's not so bad. So if we had natural numbers and addition and subtraction and multiplication and division, and that's probably plenty for actually most of the scheme programming I do. Obviously there are all sorts of things that you wouldn't get with that, but so we need a more expressive language. And I think we also need support for some methodology where, if I'm building up a program definitions at a time, doing bottom-up programming, which is something you often do in Lisps, then, I want to integrate that with my test cases. And the Barliman interface right now is not so good at that. It's like, yeah, you've got 6 slots or whatever, 8 slots or whatever for writing some tests down. That's pretty awkward, right? So I think one thing we really need to do is get serious about. What's that?
6 tests are all anyone should ever need.
That's right, exactly. One day we'll move to like 16 tests, or something. So one of the things that we probably need to get serious about is like parsing. So this is something Alex Worth is very interested in with Ometa and Ohm, to do. If we had a much better parser, the parser doesn't necessarily have to be relational, but maybe it should be. I don't know, because if you want to handle shadowing and you have a fresh logic variable as a variable binding, well, how do you know if the variable is being shadowed or not? So some of these problems that like otherwise seem really simple start to get it kind of tricky once you are allowed to put logic variables anywhere. But anyway, if we were able to, have something like Barliman, but improved, Barliman already lets you have multiple definitions and you can have helpers and stuff like that. And Greg showed this nicely during the ClojureConf talk. But it would also be nice to be able to put down a whole bunch of tests, unit tests, and maybe property-based testing, is a killer app there, but but even just unit tests, that's fine, right? And the point is, you want to get immediate feedback as you're writing some helper. You want to see, hey, is this consistent with the tests, and get feedback. And the other thing is, probably what I want is a structured editor.
Right.
Right. And a structured editor that doesn't feel something like Paret and Emacs, but it feels different, where it's like it's inserting holes. It's all hole based.
Right. Yeah. I feel like there's a lot you leave on the table, or like a lot that becomes a lot harder if you're letting kind of unconstrained strings be the programs, just in terms of, what it can infer about, what, when you're between, because it's like, if it's going to be running in the background, it needs to be running on some kind of consistent representation of the partial program. And if there's like, if while you're editing, most of the time that representation is inconsistent because you have like half of a thing with an unclosed whatever, then it's just, I don't see any good way to like recover that structure.
Yeah.
I do think that some concept of structured editing, however that's going to work, is going to be like make everything 10 times easier.
Yeah, I think that's right. And so I started thinking about, I've been thinking about this on and off, and I talked to Michael Ballantyne about this, about the structured editor, and a bunch of other people, and obviously talked to Greg about it. One of the things I was thinking about last night is, okay, so let's assume we have a structured editor and it can insert holes, sort of appropriately. What I would really want, here's what I would use. What I would want is a tool that's maximally using all the information available to it. Okay, so if you think about when I type a left parenthesis, what should happen? Well, in my current Emacs, it's going to type a right parenthesis. But if we're in something like Barliman, we have a whole bunch of information. Like, we know the context of which form we're inside of, unless there's a logic variable, in which case maybe it's there are multiple choices. But hey, is this the argument to a lambda? If so, the list could be empty, or it could be a pair. But it has to be a proper list of arguments. However, that if you're not, if you're in a function call setting, then if you're not within a quote, then if you type a left paren, then it has to be like a pair. Then it should be whole dot whole, because the empty list is not really allowed. Like, you can't have an unquoted empty list in Scheme. Right. That's not legal. So immediately the difference between where you can put an empty list and where you have to put something that's dotted, right? So that's a little bit of context, and it's small, but there are a whole bunch of little things like that I would expect my editor to know. I'd expect my editor to know the syntax of the whole language, because one thing we have in Barliman is we're not doing macros.
Right.
Okay, so that's we've made the problem easier in that sense. But on the other hand, we're like, okay, let's say we've got special forms. If you want a special form, you have to add it to the interpreter. We're not going to have user-defined macros. You have to modify the interpreter. Okay, so we're giving up something there. On the other hand, we don't have to deal with macro expansion. We always know if you see a lambda there, it's an honest-to-goodness lambda unless it's been bound. We don't have to worry about the problems of doing macro expansion and then interpretation or compilation or anything like that. We know the binding structure of everything, unless there's a logic variable sort of above where we are, and then or that's a sibling that might modify what context we're in. And so so in the best case, we know all sorts of information. We know the syntax of everything. We know all the bindings. We know, because we can follow the lexical scope of everything. We know every identifier in scope. Okay, so we know when you start typing like an L. Okay, if you start typing an L in Barliman, like a left paren and then an L, well, actually, I've got some screenshots. Let me show you screenshots, and I'll kind of walk you through this.
Okay.
See if I can get this to make sense. I have these. I've carefully picked my naming to. So I added a directory to Barliman last night called Interactive Editor Ideas, and they're not really like ideas written down yet. I mean, I've got some notes, but what they are just basically screenshots. So I don't know if you can you see that?
Yeah.
So basically, okay. So here is append, and you can see that we have some holes like A and B, right? And we've got a bunch of tests here on the right. And this is enough to synthesize it, but let's forget the synthesis, okay? Let's just think about this as an editor. And we want to know, as we're writing, is our code compatible with the tests, right? And in this case, it is compatible. In fact, you can see it's synthesizing, okay? So think about it as we're editing, you know, this expression right here after cons. Okay, so we're editing this car thing. Okay, so that's the context in which we're going to think about editing. So in this case, we type the right thing, car of B, and it works. All right, so now let's look at a couple other variants of this. So here, yeah, so here instead of typing cons of car of B, I type cons of B. Okay, so that should be car instead of cons. And now you can see that 3 tests fail. Okay, so imagine if I had like an autocomplete. Let's see, I've been looking at some autocomplete stuff. Bring up one of the autocomplete things. Yeah, is it this one? Yeah. Okay, so let's just kind of think, you know, about how autocomplete normally works. You know, we're typing some text, and now we see all the possible completions, right? So that's our autocomplete model, something like that. And you know, imagine if I had just typed a C here, right? A left paren and then a C. You know, so if I type a left paren, because we're not within a quote context, really the structured editor should do like C dot or B dot C or something, right?
So by the time you type CO, it knows that there's nothing bound in the environment that's going to make that succeed.
It might. That's the whole idea, right?
Yeah.
So if I type C, okay, what are the options? Well, it knows what's available, because in the original environment we have cons and car and cdr, right? And I think those are the only things that begin with C, right? So you could see if I type C, immediately it could drop down and show you car, cons, car, cdr, cons, right? So we could do just standard autocomplete, except this is not just syntactic, it's based on what's in scope. But furthermore, we could actually strike out the cons, because we know that cons is not going to be consistent. So what I'm imagining is, you know, like a drop down like we saw on that web page. Okay, yeah. So imagine like this dropout, but we actually can strike out, you know, some of the options, and then to the right maybe say why, or if you mouse over or you select it with the up and down arrows, it shows you which tests would fail based on that possible completion. Okay, or if I'm typing, you know, if I type cons. Well, I guess we can already see here kind of where it's going, but maybe if I'm typing cons, it has a drop down, and it's like, well, here are things that you could have put instead of cons that might have saved you.
Makes sense.
Right, sort of like a local like a local repair. And you might even have to do, because it takes a little time to run this code. What you might have to do is, you know, some sort of super dynamic autocomplete, where it's like it's showing the options, and then as it's running these tests, is then dynamically striking them out. You know, some of the options, and maybe you could do some memoization or tabling or something that would help make that a little faster. I don't know. Or I was thinking, like, you know, what if you ran this on 10 Amazon X1 instances and had 1,000 hardware cores, could you get the latency down enough? Like, once again, taking inspiration from LK, what if we actually use the hardware that's going to be available 30 years from now, right? And so if we bought, if we bought time on 10 Amazon X1 instances, that's like hardware from 30 years in the future. And it's a little bit expensive, but we would at least be able to test out, kind of how this would work if you had just like massively parallel hardware.
Sure, yeah, that makes sense. I like that autocomplete framing, and I think I'm starting to see how you might go about thinking about the structured editor setup. Another thing I was kind of just sort of thinking about earlier, the concept is going the other way and letting the synthesis write the tests, right? So like, say you've written a function that maybe you wrote the test first, a few tests first, maybe you didn't write the test first, whatever. Having the function you write generate a bunch of possible inputs and outputs that you can go through and say, like, yes, that's a correct one, that's a correct one. No, that shouldn't be an input and output, and have it go back and add that as a failing test case or a passing test case or whatever. And kind of, some interface there where you write a little bit of something, it gives you kind of a list of input outputs. You kind of go through that, it adds tests and kind of comes back with that cycle or something like that. That makes sense. I haven't fully worked out the details, but I'm trying to think about how to write tests using the partial specification.
Yeah, I think that would be really cool. And have you seen spec in Clojure spec?
No, I don't think so.
This is like the new major feature for Clojure.
Mm-hmm.
I definitely recommend looking at it, and I definitely recommend looking at some of the talks by Stu Holloway on spec. So spec, I think it's just a really beautiful piece of language design, personally. But it combines a whole bunch of things like a unit testing, unit tests, and property-based tests, and the ability to generate input, like you're saying, like fuzz testing, a whole bunch of other things, documentation, in sort of one integrated package that's built into Clojure now. And so one of the things that I'm very interested in is, could we have some of those sorts of capabilities in a tool like Barliman, and eventually, even have a Clojure version of Barliman that really integrates all this stuff. But
right.
Yeah, spec does some of those things, and I definitely recommend looking at spec to see how they combine all of these things in a very nice package. But yeah, I totally agree with you that would be really handy to try to figure out, okay, so here's my definition. Show me what some of the inputs and outputs look like, so I can do, basically a sanity check and make sure, does this look reasonable?
And I also kind of wonder, and this is the sort of thing that you really wouldn't know until you actually like sat down with it and tried to do this, how much of the program synthesis itself could be driven just by like, thumbs up, thumbs down on proposed tests, right? Like, I think there's probably not enough information in this, but like you can kind of imagine the sort of, utopian version of this is like you sit down with a totally empty definition and it says, okay, well, let's just try from like, the plus function. How's that for you? And say, no, it's not going to have any numbers. And say, okay, well, let's try throwing some conses around, like how much could you actually usefully do, like from a very underspecified function to just sort of, approve tests and have it, get enough, get quickly enough to the tests that will actually drive it to synthesize what you want, if that makes sense, rather than writing it yourself. I don't really know how that would work or how well that would work or what you'd have to do to make it work, but just kind of playing around with it.
Yeah, I'm not 100% sure I understand what you mean, but I do think that something more of a conversation could be really helpful. Like maybe you specify what parts of the grammar are allowed. That's something that you see from, like the Saigas work or Armando Solar Lozama's work, things like that, where you pick the subset of the grammar. You could also imagine, something like Escher, where the human's basically acting like an oracle. I mean, the human's kind of doing that with Barliman already, because Barliman will make some ridiculous guess, and then the human's like, well, that's not right. I need to add a test that shows why that's not right.
Right, exactly. And that's, yeah, so like what I kind of had in mind, and I don't, I think this is kind of like, I don't think this would work as specified as an interface concept, but just to sort of like, imagine a world in which it did, and then so I can kind of explain the basic principle, and then figure out later how to fit that into a more comprehensive approach. But like, I'm kind of imagining an interface paradigm that's like, okay, you want to write append. Well, you start with like nothing. You start with like an empty form, and then it says, should it receive 1 and output 1 just because it picks a random function? You're like, no, it shouldn't. And it's like, okay, well, should it receive a list and output this pair or something like that? And you're like, yes, it should, or something like that. I think from no seed information, it would take a long time to like start guessing the tests that would actually usefully drive synthesis. But I'm kind of wondering if you started it off with something and then let it figure out what instead of having the person figure out a test to prove why it isn't right, have it kind of generate some candidate tests and have the human select one that does this, or like shows that this, or select one that shouldn't be true, basically, or something like that.
Well, okay, so I can imagine a version like, so as we're writing append, right? It's got some structure, but not enough structure to actually synthesize it all. Mm-hmm. Then it's going to be like, all right, I've got a candidate solution, right? And here's my best guess down here. And the best guess window often displays code which is incorrect. Right. And so what it could do is say, all right, let me generate a couple of tests that aren't in the test suite already. Right? There's sort of small tests that would show the behavior of this proposed function. Right. And the human then can inspect it and decide whether or not this looks right. And if not, they can like, so nope, that test is right, but this test is wrong type thing.
Right, exactly. Yeah, and then it automatically adds it to the test suite.
Yeah, exactly.
Yeah, that's kind of what I meant.
Okay, yeah, I could. So I think what would happen is probably in the very beginning, it's not going to work very well, but as you add more and more structure, that's going to start working well.
Right. Yeah, it doesn't seem like it doesn't seem like you could usefully get from absolutely no information just by like a guessing in the total space of programs or something. But like you could, in fact, you could even kind of imagine it as like, and this is kind of getting less clear on how exactly we would implement this, but just sort of, thinking, seeing where this goes, running with it for a moment. You could almost kind of imagine it like a 20 questions type of thing. Like, is it an animal, plant, or mineral? Like, does it return a number, a list, or like a whatever, and like add that constraint, and then
I was thinking about that actually. 20 questions animal game. That would, and I was also trying to think from an educational standpoint, or for someone trying to learn programming, that actually might be a very interesting exercise.
Huh.
Right? To try to teach them to think about programming a different way, or think about the problem a different way. And another thing I was thinking about in that vein, let's see if I remember. Oh yeah. So one of the screenshots that I wanted to show you, see if I can find it. It's pretty funny.
Yeah. I
was just going. Oh, sorry. Go ahead.
I was just curious if Barliman currently lets you add like constraints instead of tests, like this it shouldn't be a symbol or should be a symbol or whatever.
It doesn't, but it should. It absolutely should.
I was just wondering if that was like already part of the syntax or whatever. Anyway.
No, it doesn't let you do it explicitly. I mean, Greg's figured out a lot of ways to encode interesting things, but it's a little bit like standing on your head right now. And I think if it did let you encode those things, that would be really nice.
Sure.
And there's no way to give types to things really, right? Like we can't say LNS or lists. In fact, actually, for true append, S doesn't have to be a list. S can be any value. So you have to be a little careful there. But
indirectly, yes, as part of that code. Fair enough.
But yeah, so the ability to specify those sorts of constraints would be really helpful. Sure. Or any sort of constraint, saying this thing's a symbol, this thing's a...
Yeah, I mean, it's an obvious thing. I was just wondering if it was already there or if it was just kind of on the list somewhere.
Yeah, it's sort of on the metaphorical list, and this is where maybe we need to kind of go back and start spending more effort on sort of the IDE and cleaning things up and doing some more engineering to try to add the finite domain constraints and make it easier to express the constraints on things. Like if you had an argument that was a number, you'd want to be able to put a number constraint on it, right?
Right.
I mean, that would help a lot.
Yeah.
That should really help. but there's no way to say that right now.
Yeah.
Okay, so for this definition of append, notice that we have a let, right? And even though you really want to do is have a car, I call it a car, like it's perfectly fine, it synthesizes it, right? Yeah. It's just like a let nil, right?
Yeah.
And I remember Jerry Pournelle, who's this science fiction writer and also wrote for Byte magazine for many years. He would give advice to aspiring writers, and one of the pieces of advice he gave was that here's how to learn to be better with grammar. Mm-hmm. He said take there was some program he likes that has really good grammar check, and basically try to fool the program. Try to write the same sentence in a whole bunch of goofy ways, and see if you can fool the grammar check. And this kind of feels like that to me, right? This seems like it's actually just fun for me playing around with Barliman, even though the interface is kind of not great. And the structured editor would make this way better, and the autocomplete would make it way better. But it was just kind of fun to like, hey, what happens if I put a let here? It's like, oh, no, it's fine, right? And I started playing this game of like, okay, can I fool Barliman? Like, what goofy things can I write and still have it like work? Mm-hmm. And so I started thinking about autocomplete, like, actually so one of the examples I was thinking of is, say you typed an L. So here's what are all the possible, say you just type the character L, like what would this super autocomplete be able to tell, right? Well, there's lambda, let rec, list, and it turns out that we have a variable called L. Okay, so those are the only things within scope that begin with an L. So if you imagine we have the structured editor type thing, you type an L, and you have all these completions. One of them's lambda, but lambda, it turns out, fails 3 of the tests. So in the drop down, it like could strike out lambda after a second of thinking or whatever, right? Mm-hmm. And what else do you have? You could type in like the identifier L. But that's wrong because it's an application context, like doesn't even make sense. It's a list. But anyway, it's going to fail these 3 tests value-wise, right? So that doesn't work. So those 2 options are gone. And then here's let. Let actually does work, but it's kind of works in a goofy way, and you might be able to detect that it's working in a goofy way that like let's not actually doing anything. You could probably just say, hey, like this is basically the identity. So it like works, but it's not, like list doesn't work. And let rec works, but let rec also is basically being used as the identity. So you could plausibly have something where you type the character L, and within a second or two, it's shown you that all of your answers either don't work or they're the identity, so that's kind of pointless. Mm-hmm. Right? That would actually be a really, really cool feature. Mm-hmm. I haven't seen any editor that does that. Have you all seen an editor that does something like that?
No, I mean, I don't have a wide range of editors. Nothing comes to mind, certainly.
So, and I totally think we could build that like today. Mm-hmm. So that would be something that'd be really interesting to explore and play around with, and I could imagine actually using that thing. So anyway, and I think, let's see, I might have had 1 or 2 other thoughts about that.
I'm just getting on this 20 questions idea. Like I'm kind of wondering now, what 20 questions could you ask to figure out what, right? Yeah,
well, I mean, there are some questions you standardly ask, which is like, is it recursive?
Sure.
Right. Yeah. That's the first question you ask. Is it a recursive definition? If not, there's no reason you should be looking at recursions.
No, that's true. Is it recursive?
Does it have a helper?
What are the
types? Does it have an accumulator?
Types of inputs, in particular, then like, assuming the inputs are compound types, the relationships, like the relationships among their contents. or something like this, like is, if it takes and returns a list, is the return list the same size? Is the return list maybe shorter, right? Kind of some map versus select. Is it return a non-list?
Yeah. That's right. Or the elements of the list the same, like in a sort?
I kind of wonder, like this is, question answering is definitely a thing. And I'm kind of almost now wondering if I could fit it into the learning thing I'm doing. I don't know. I'm gonna think more about this 20 question program synthesis.
Well, another form of learning could be, say people were willing to try the question answer thing on a whole bunch of programs. You could also learn which questions turn out to be most discriminating.
Yeah.
Right. And so actually, or you could probably actually go backwards. You probably don't even need any human input, right? Like if you actually had the final program, you could infer those properties.
Mm-hmm.
So if I gave you, like, if we looked at the corpus of Shea scheme and looked at 10,000 definitions or something, assuming we could, or say we had a whole bunch of scheme definitions or racket definitions or closure definitions or Smalltalk definitions or whatever. If we actually had the final definitions, then we could look at those and say, okay, well, with these candidate questions, which questions actually turn out to be most discriminating, most often, or whatever, and we could, order the questions by that ordering.
Yeah, no, I'm gonna think more about this because it's actually like not so far into the realm of the ridiculous that it may not actually have something to offer. I don't know.
Well, not only is it not ridiculous, but certain questions we really should be asking.
Mm-hmm.
So, for example, one question you could ask up front is whether or not it's recursive.
Mm-hmm.
Another question is it variadic? Does it take any number of arguments? Or something like that.
That'd actually be a great thing.
Yeah, and if you knew some of those, I mean, like if you knew, say you knew it had to be recursive, right?
Mm-hmm.
Then you might actually be able to, well, okay, if you know it's recursive, then you have to have at least one base case, and you have to have at least one recursive case.
Mm-hmm. This could also be kind of a generalization of the test case generation, where like asking if one particular input output satisfies it is kind of a special case of asking about various other kinds of constraints or invariants of the starting environment, like whether or not it has a recursive call or something like that.
Yeah, and you could even have something like you could have the questions like tied to the editing. Mm-hmm. Right. So I'm editing this I'm editing a pen. Like, let me bring up.
Like if you add the recursive call, then it knows it doesn't have to ask about a recursive call.
Yeah, or it could be the sort of thing where, like, it could be asking me, the conversation could have the context of a single line. Like, I could tell the system that this line is a base case and this line is a recursive case, right?
Yeah, that makes sense. I see.
And so then you could have a conversation at a finer level of granularity.
Yeah.
And if it knows the first case is a base case, well, then there's no need to look at the recursions.
Okay, this actually has some legs.
Yeah, and in fact, I mean, this actually is very similar to how the sort of program methodology you teach students.
Yeah, I was about to say, I don't know what it is, but this feels like the kind of thing that should have pedagogical implications.
Yeah, or here's like another thing. Like, say we had a cond, right? Mm-hmm. So I have a cond, and I have, say, 3 cond clauses, right? And I don't know, like that. Okay. If I tell you that the second one's a base case, what can you tell me about the first one?
Mm-hmm.
The first cond clause is almost certainly a base case if the second one is a base case, right? I mean, it doesn't have to be a base case, but it probably is.
Right.
And so if you had to guess whether or not to look at the recursions or treat it as a base case, you'd be much better off probably treating it as a base case most of the time.
Yeah, and that's really kind of in the area where the like statistical stuff is like, could be a base case, but probably not, is what we want to know about that.
Exactly. But if you look at how the design programs works, or how Dan Friedman teaches students to write recursive programs, or how Kenichi Asai, like Kenichi Asai has a web interface for helping students write programs.
Mm-hmm.
And it has a bunch of checkboxes on it. And for each program, for each definition they write, they're supposed to check, for example, whether or not it's recursive. Right? And so he is explicitly using this methodology to get students to think about the behavior of the program. Like, is it recursive? Does it have a helper? Does it have an accumulator? Those are 3 standard questions that we would ask students normally. Maybe the accumulator one's a little more advanced, but certainly the first thing we'd ask is, we ask questions like, what's the name of the function? How many arguments does it take? Was it going to return? And is it recursive, right? Like, you can't write that information down. Like, you don't even start writing a function usually.
Yeah, no, that makes sense. And that's particularly, I remember that conversation. I don't remember the details exactly when we were talking that hangout with Molly about, what kind of feedback a computer could give, right? So, this kind of feels almost like, this is what you're saying, I think, really, right? That the kinds of questions the system needs to ask a programmer to know what function he's trying to write are also the kinds of leading questions that one might ask a student if you know what function they're trying to write and are trying to prompt them to figure it out, right? Because they're the questions they should be asking, and you're sort of prompting them. Yeah, no.
And another thing is, another question to ask is, if it's recursive, which arguments are you recurring on? Right? Like append, we're recurring on L. And as soon as we're recurring on L, and you can look at, and L's a list, then you immediately know that you're going to have a null check and you're going to have a pair check, basically, or an else check, right? Like, bam. So you could at least fill that in. Now, maybe there's a clause in between, but you're going to have at least those. And in fact, you're immediately going to have like a null. You're going to have a base case that's a null, almost certainly. You're going to have that, right? And so that, like, you just know, you don't have to know anything else. You just you're going to do that, and and that's plenty of structure to start speeding things up. Maybe you're going to have an extra clause, but you don't have to, because you could always do nested conditionals in the else. Another thing you could do is maybe say, hey, we are going to assume, or we're going to allow structure here, or part of this conversation is that, okay, well, we'll say E isn't going to be a cond or an if, because if it was, then you would just have another cond clause instead. Right. So you might be able to rule out or restrict the grammar to avoid a conditional at that level. So there could be some style guidelines, and that could be part of the conversation. It's like, hey, can I assume that, there's not going to be a conditional here? Right. So I
hopefully show up very clearly in the kind of statistics about how frequently cons show up inside else's.
Yeah, exactly. Or if you are going to do that, maybe you want to refactor it. Like, you could also have some refactoring built in. It's like, hey, I notice you have a con inside of this else. Is it okay if I pull these out? Or do you want me to pull the clauses out? Right? But yeah, I think these ideas, like, first of all, asking if it's recursive. If it's not recursive, there's no reason you should be synthesizing that. Asking if it's variadic, asking if it has an accumulator, asking if it has a helper. Right.
And asking if test cases should pass.
Yeah.
Kind of fits right into that.
Yeah. So like, if this should have a helper, you could, the system could immediately create a dummy helper that has some name that you could then use, like -aux. So if you're defining append, then you have append -aux, and now you have another name and scope right? And that's an important thing to know when you're trying to decide whether the program can be completed and, you know, all that sort of thing.
Mm-hmm. "20 questions program synthesis. I have to think more about this."
But that would be great to have in an IDE, right? I mean,
Crazy enough to work.
You know, you've got all of these things in your head. You know when you're writing this definition whether you think it's going to be recursive or it's going to have a helper, probably. You know, or maybe at some point you realize you need a helper, and now you're like, you know what? I think I need a helper, and now the system maybe can kind of help you out as a jam and refactor a little bit and create this helper and let you keep going. So when you think of it that way, like our IDEs today are so stupid.
Yeah.
They really are not giving you the sort of help, and they don't really match the process in your head. Like if you're, I mean, I guess one way to think about it is if you were pair programming, right? What information would you be telling the partner? Or if one person's typing, the other person's driving, right? But the person typing can fill in some of the details, but the person driving still has to give them a high level kind of sketch of things. What information would they give in that sketch? And one of the things is, okay, this is going to be recursive. We're going to recur over the first argument.
I kind of wonder, like, speaking of the pair programming paradigm, whether there's like any way to sensibly add like just one term to an incomplete program rather than jumping all the way to the solution. Like, you know, obviously, usually it doesn't actually know what term is next, right? Because it's kind of searching everything and it's kind of trying a million things, and it's not obvious which branch is going to be the winner. But like if you had a kind of a, you know, some statistical search where it said, you know, this next one is probably a variable. I'm going to try adding that variable here, show that version of the programmer while I go on and do all these other things and see if they respond to that at all, because that's like kind of like an implicit question, like complete one term, see if the programmer reacts and use that as information, but keep searching normally beneath the surface.
Okay, that's a really good point, and that was one of the things in my notes I wanted to bring up is that, you know, for this idea of autocomplete, you know, if you type a C here, well, you could have a car, a coulter, or a cons. I think are the only three in our current environment. Car works, but cons doesn't. Coulter works in a goofy way because you can always like take the coulter of a cons, right? So once again, it's kind of, you know, you could sort of rule that out because it's undoing the work. Like you could simplify it. Let me put it this way. You could simplify that expression. So, you know, while you could type it, the system could tell you, hey, you know, you could type this, but here's a simpler way to write the same thing, right? And at the same time, not only could it be telling you which things are, you know, this doesn't work because it's not in scope. This doesn't work because it's grammatically incorrect. This doesn't work because maybe the types don't check. This doesn't work because it fails these tests. It could also be showing you, or these things might work, but this thing could be simplified. It could also be showing you statistical data based on usage from some corpus. And it could say, okay, I'm going to order these answers, you know, partly by whether or not they're correct. They could be correct, but for the correct answers, I'm going to order them also by percentage. You know, what comes in most likely. If you're inside of a lambda, you're likely to get a conditional or another lambda. Or maybe a procedure call, but you're not likely to, you know, maybe have a number or something. Maybe that's less likely. So whatever it is, like, you know, you could have as part of your autocomplete this probabilistic information or statistical information.
You know, it also just occurred to me just now, thinking about a question. So, like, you know, obviously, if you have a literal test case here, or ideally a constraint in a more, you know, complete version of Barliman, then you can literally write the test with. You can imagine writing the test. It's less obvious how you would sort of express some of these tests, but you can imagine having the answer to the question, you know, no, it should not. Because right, if someone says no, it should not be a recursive function, they could be wrong about that, right? And so that's really like another test case that you would want to check against and say, if we keep this assumption valid, then there's no way to complete your program. And so, like, having, you know, non-recursive just like you know, show up alongside all the other tests, even if you don't necessarily express like that symbolically if it's like a more complicated thing to express, but you could kind of still represent it as a test case that can fail and be removed.
Well, that's a good point. So you can imagine if you had some checkbox, let's say, that said whether or not you think it's recursive.
Right.
You say I don't think it's recursive, right? You could still have one synthesis task running in the background, assuming it is recursive. And first of all, if that can come up with a recursive definition, maybe that's shorter than the non-recursive definition anyway. And so maybe you want to suggest that to the programmer. Maybe they're wrong, or maybe they're wrong, and one fails, but the recursive definition succeeds. Then you want to give them that information. But the other thing is maybe even the recursive version at some point fails because they've really gotten themselves into a hole. And then you want to give them that information. It's like, hey, even if this is recursive, these 3 tests still fail with the definition you have. So you could give them a lot of very contextual information. It'd be very rich. Yeah, I think we could build a really amazing editor as far as those capabilities go.
Yeah, it sounds like the first step is figuring out what this structured editing paradigm is going to look like.
Yeah, I mean, I do have like a fairly strong idea now of what I might want. Do you have any ideas of how the structured editing would work?
I'm just kind of thinking about it now.
Okay. Well, I won't tell you then. I don't want to like spoil your pristine mind because maybe you'll come up with something different. But basically, the thing I have in mind is like a somewhat tweaked version of something that Michael Valentine suggested and we talked about a little bit.
All right. Well.
But anyway, I think there are probably multiple ways to do it. But I think probably more important than the exact design is this principle of you want, the sort of Kent Debug has this macro users bill of rights, and so we should have like the IDE users bill of rights, which is like for things like autocomplete, the system should use maximal information, right? If a human could look at it and infer that no identifier beginning with the letter L could possibly go in this context, well, then why in the world shouldn't the IDE be able to tell you that?
Right.
Or could tell you that, okay, if you put an L there, the only completions that would work would be let or letrec, and both of those would actually be trivial because those are like equivalent to no ops, right? That information should be given to you. And you should assume that maximal context is always in place, that like if you type a left paren, if the system can infer that a right paren immediately following doesn't make sense, then it should never even give you that as an option. Right. It should just like, nope, it's going to have to be a pair of 2 holes. So go ahead and fill that in. Right. And there are probably plenty of times where there's a single completion where like I type one letter and there's a single completion. So like, go ahead and fill that in. Or at least show me what would happen if I hit return or something, or if I kept typing or whatever it is, right? And also like maybe that local repair where it's like, it looks like you're down a dead end. Here are some suggestions that would not get you stuck at this certain point. Maybe you still need to back out more. Maybe you're already stuck, but you're definitely stuck now. And so here are some things locally that might help. I don't know. Yeah. So anyway, this principle that if a human who knew semantics of scheme and looked at the test cases and all that, and look at which variables are in scope and all that, could rule something out, or give you additional information like this could be simplified trivially, then you should be getting that information in real time. It'd be very interesting to see what such an editor would feel like using.
Yeah.
I have the sense that like once you got used to it, like you really wouldn't want to go back.
Probably true. I get that kind of feeling now coming into like, text-based languages where I don't have a lot of tooling for them, where I'm sort of so used to just kind of hitting buttons and having lots of system things fill themselves in elsewhere. And
yeah. All right. Well.
Yeah, so what's the next logical step towards bringing all this to some form of realization?
One thing so one thing I would like to do, here's what I think the next step is. I think the next step is for us to, kind of write down these ideas and do some paper prototypes and do maybe some more brainstorming and exchanging ideas and, write up a little bit about how we imagine it working.
Mm-hmm.
Right. And in particular, then we can start showing it to other people and get their ideas.
Mm-hmm.
Another thing we can do, like, so for example, we're sharing enough context that I think this idea of the super autocomplete is kind of clear, but it'd be nice to really, have some, low fidelity paper prototypes that show you exactly like what it might look like, right? Or the 20 answers or the 20 questions, right? Like what might that look like? What might a user interaction look like? Kind of go through an example use case and show what the questions would be and show some of the screen, paper prototypes and kind of write that up. So I think that's actually the next thing because, we could try implementing it. But I think probably the first thing to do is try to get down the ideas and try to refine those a little bit.
You have too many competing partial ideas to know what to implement.
Yeah, and also part of it is, there are people who are really fast at coming up with nice user interfaces or prototypes and stuff like that.
Mm-hmm.
And, like far faster than I am. Or maybe we come up with something that makes, it may also be the sense that like we have this kind of grand vision. So I guess part of it is, okay, we want to try to start thinking, what would our idea of sort of the ultimate IDE that we would, it doesn't have to be the ultimate idea of like, what features in an IDE would for us make it compelling enough that we would want to use it today, right? Even if the language support isn't 100% complete, even if it's a little slow, what would it look like if we had to use these tools? What features would we want, right? Like what features would be so impressive and so important, so useful that we would be willing to use these tools, right?
About 100 people would try adopting them.
Yeah, exactly, right? Like so can we have a vision and try to articulate and maybe even write a paper, like at least a white paper, if not a published paper. But this is a sort of thing that I think could be published. Where we try to show, what we want to get to. And right now, like the current Barliman is far from it. But I think we're starting to get a pretty good sense of the fact that we could have a way, way, way better tool. And that it would feel unlike anything that's ever been built. And start trying to put together these ideas like the autocomplete and the 20 questions and other features. What would that actually look like? And that's what I actually did before I started working on Barliman. I did a bunch of paper prototypes and screenshots, sort of, fake screenshots. And Barliman hasn't turned exactly into that, but it was very helpful in thinking about it. And I could show it to people. And I think we're at the point now where we could start doing that again and start showing it to people who are really interested in interfaces and, get feedback from them. And maybe also get some people who are really good at building interfaces to get excited to work with us on it. And at some point we'll have some idea of maybe like, okay, well here's like a longer term vision. What's the shorter, which of these features would be the most bang for the buck? Let's try to implement that. Another thing to think about, I think, is what could you use with some of that information? Like, so say you had the 20 questions. Like, say you knew that a certain clause was of a cond was recursive,
Mhm.
or a certain other clause wasn't recursive. Like, how could we use that in Barliman? You know, or the relational interpreter. How could we use that information to try to make things more efficient,
Mhm.
or to get better refutation or whatever, right? You know, so if you know that something's not recursive, you probably can do much better with refutation, is my guess. Because as soon as you start doing recursive calls, if the program hasn't been completely defined, I think it can be hard to know whether or not you're going to be able to find a solution.
Mhm.
You know, Greg can probably speak to that better than I can, but that's the sense I get is that once you have that recursive call, then it gets harder to refute things. Whereas if you know, hey, this is a base case, there shouldn't be a recursive call here, then you probably can get stronger refutation. Do you think that would be correct, Greg? Anyway, so we can start thinking about those sorts of things, like, you know, not just what would the user interface or the flow of a conversation look like, but also what would we do with the information from that? Or we could drive it the other way. Like, what are some of the problems we're having, either with synthesis or refutation or whatever it is, or maybe language extensions, like we can't handle every part of the language right now. Are there things we could do in the interface or in the conversation or the autocomplete or whatever that would make things easier for us? I don't know. So we could make the language a little more extensible. That I'm not sure. But anyway, it seems like there's a whole lot here. And so that's a direction where I think we can start going now, and we can at least start designing stuff. And so, you know, when I visited Hark and gave the demo, you know, the Hark folks are very, very interested in interface. And also education. You know, interface, education, programming languages are three of their main four areas. And you know, basically something like Barliman is hitting all three of those, or Barliman and Galadriel are hitting three of those four areas. I don't know how virtual reality fits in, but maybe we'll have virtual Barliman at some point. You know, it'd be like the Matrix or something. I don't know. But it seems like if we came up with a really nice description of things that, and some paper prototypes and all that, that'd be great.
Makes sense.
So that's what I'd ask you to do, is like write down your thoughts and maybe draw some ugly pictures.
Gotta think about this 20 questions business.
Yeah, and you know, could you come up with like a scenario? And I'm serious about like trying to do like a white paper or a position paper or something like that. And I think like OOPSLA, for example, would probably be, you know, they're probably either at OOPSLA or Dynamic Languages Symposium or one of these other places like at OOPSLA that would probably be interested in this. Or HCI conference or something like that. Anyway, but the point is, I think we should think very hard about that vision, and I think we actually have a very compelling vision. Part of it is, you know, you and I and Greg and Michael Ballantyne kind of know how this could work, but it's still a little too much in our head. I mean, the whole point of Barliman was to try to show people like what you could do with this technology, right? And in some sense, we're showing it a little bit, but I think people get maybe caught up too much on the synthesis aspects, where I think there's some really cool things we could do just with the IDE support that are probably more impressive right now than anything we can do with synthesis. But I mean, it's no problem having synthesis if we can actually fill in the rest. I mean, that's the other thing with autocomplete, right? Maybe at some point the system actually thinks it knows the completion as an autocompletion as well, right? So anyway, I think we could build something really interesting, and at a minimum give an awesome Brett Victor style demo. Right. And you know, once again, it may be the sort of thing where like we have to live in the future and get 1,000 cores on 10x1 instances, and like, okay, we can only do this demo, you know, once a month because our bank accounts can't take it, but once a month we can give a really awesome demo. That kind of thing. You think about the mother of all demos, right? Like imagine the amount of work that went into that demo.
Yeah.
The amount of hardware they had and the cost of it. Like what if we were, it's like, all right, well, okay, we're willing to like put on a $10,000 demo, right?
I was just reading about that demo, and according to the thing I was reading, apparently Engelbart is sitting up there with his headphones, and the whole time he's hearing like English or someone in the background like swearing and complaining that things aren't working and he can't find something. Like it's like sitting there trying to do a presentation, and like and the screen behind him could just like turn off, and he
That's awesome. Yeah, I'm reading. Speaking of those books, I'm reading a couple of books right now. Tools for Thought by Howard Rheingold, which also is a lot about this. And also I'm reading one called Bootstrapping, which is all about Engelbart. It's on Engelbart. It's like an academic treatise about Engelbart and his ideas. And there's also a New Media Reader, and I'm just reading a bunch of papers on this stuff also. But it's really interesting. I get jazzed, and I also get like kind of depressed thinking about this stuff. It's like, oh, we got so far to go. Or why am I still using Emacs?
Right.
Yeah, this was the complaint when I did a hangout with Alex. He was like, I'm a little disappointed you're still using Emacs. And it's like, it took me a while to kind of realize what he's getting at. And it's like, oh, as well. Either that or I want super Emacs. Like, I mean, there's nothing wrong with Emacs in theory, because Emacs is so extensible. You could build the things we're talking about inside of Emacs. That's fine. But the Emacs I'm using and the modes I'm using are so primitive compared to like what I want that it's like a joke. It's a complete joke.
Right.
It's like, I've got a supercomputer, literally a supercomputer compared to anything that people had.
What Emacs was originally
30 years ago. Yeah. Yeah. I mean, compared to when Emacs was originally written, my laptop's has more computational power than all the computers in the world when it was written. But it doesn't act like it.
Yeah.
It doesn't act like it at all. And I have access to the internet. I have access to all the code on GitHub and all this other stuff, right?
Right.
It's like, why is that not taking advantage of anything? That's the other thing you could have in an autocomplete is looking at GitHub, looking at the code. Like there's this DARPA for like big code, the Muse project, which is kind of like that, right? It's like, well, why can't your tools look at all the code on GitHub and look at that as for like your autocomplete? It's like, hey, I think you're writing append.
I may have seen that somewhere before.
Or it could at least like fill out the skeleton. It's like, hey, it looks a lot like this code. Like, let me fill that in, and then you can, yeah, exactly. Stack Overflow driven programming. That's another thing people do, right? I mean, honestly, I was trying to figure out something about autocomplete last night, and of course, I Googled it, and Stack Overflow. I was on Stack Overflow looking at these articles.
Like have your IDE be an intermediary to Stack Overflow, where it asks you ask it asks Stack Overflow, it comes back and finishes the program.
Yeah. That's what we'll do. We'll flood Stack Overflow with all these questions in the 20 question style, right? Like, is append recursive? And the answer is yes, it is. In append, which argument are you recurring on? You're recurring on the first argument. Well, this is fun thinking about these things. I really legitimately think we could make the best programming interface ever made for an IDE. I'm not kidding. I think we can. I don't think it's like a small amount of work, but I think it's possible. Like when I think about the things that we could do, and I think about all the IDEs I've ever seen, like they all leave a lot to be desired, I think. Now, we're doing it for this tiny little toy language, right? And it may require staggering amounts of computation to do it. But if we were willing to run these things on 1,000 cores and put in all the engineering efforts, I think we could do something really amazing. Scaling it up and handling JavaScript or handling like third-party libraries and all these things,
I think
that's a different issue.
I think a lot can probably be done just kind of in figuring out the interplay in the interaction flow, because I feel like, there are a lot of kind of small questions and small answers that it's easily fast enough to do, as long as we can figure out how to mediate between like the person and the environment. Rather than just like, here are a couple of test cases, search the space of all possible programs and figure out how to complete this. If you get the interaction right, then it may be more than fast enough to like have a, create a useful experience out of it. But I don't know, to figure out the details there.
Well, you could have an autocomplete, for example, based on the probabilities. Here's something for you.
Right.
It may be that you could have a sort of a self-adjusting autocomplete where I type the character C, right? And not only can it figure out that the most likely thing is car, or like say let's take a step back. That example with the pen is maybe a little too small. You need a somewhat bigger context, but I can imagine something where maybe the cons part of the append, where like you type left paren and then type C, and now it's trying to figure out, is that car, is it cons, is it coulter, blah, blah, blah. And not only would it be able to tell that it's going to either be a coulter or a cons, or a con. Oh, wait. It's going to be a coulter. No. If you type a C, it could probably rule out. Actually, that's a good question. Let me try this. I wonder if it can actually rule this out. Basically, what I'm trying to say is like it maybe can chain it. It might be able to say, hey, not only do you need to have a cons here, but furthermore, I can tell you like, the next several parts of the expression that you're going to write. Right? I can kind of rule it down, or I will suggest something that has by far the most high probability based on all the other code I've seen.
Right.
In the corpus. And where it's like, hey, it's probably this, and furthermore, this is consistent with all your tests.
Right, and that does seem to be like that should be something that's very much, if you get the probability thing working at all, that should be a natural extension of it, right? Because that's exactly what it's doing. It's like, what's the most likely next branch to take? Yeah. And I'm just going to show the next step of it to the user rather than just use it myself.
That's right. Yeah, I can't rule out car and coulter because you can always cons up something. Yeah, I'll have to think about that a little more, but I think there's a lot we can do here.
I also kind of, that's what I was kind of talking about the other day, and I'm kind of getting ahead of myself, having not quite finished the probabilistic thing to figure out how to use the probabilistic thing, but thinking about how are we generating these likelihoods when we haven't seen most combinations of most things, right? Like, well, it's kind of like you were saying, when you have the let that it can just work around, right? If we generate a bunch of sample programs and realize that these vary just by this useless expression being inserted here that does nothing, turning that into training data that says, I know this combination is unlikely because I generated a bunch of test examples in which it did nothing. So kind of a self-training thing I'm trying to work out. I think I'm close to getting it either working or discovering it can't work. I just need to integrate things a little bit.
Well, I think we're at the point where we should probably just start writing up our vision for what this thing is going to be in the future. Right? Like, what would we want this editor to work like 5 years from now?
Mm-hmm.
I mean, whether it'll take 10 years or 6 months, I don't know. I mean, partly it depends on the resources we put on it and stuff like that. But the sort of the idea of, what do we think is achievable with our current without any sort of new magic is sort of like, okay, these are things that we think are achievable, right? and here's how it would integrate in, and you know.
One of the things I've been trying to think a lot about, which is, you know, I think very much in this vein, but like a slightly different take on it, is like representation learning stuff, where it's like, instead, you know, one context, like the synthesis context, very much foregrounds the function and assumes you have, you know, what data is coming in. But there's also the context where you have, like, you know, the three functions your module exposes and what those input, and then kind of within that, it's like has to figure out how to build representations such that you can write all those functions in a natural way, or something like this. You know, it knows that
I'm not sure I understand that.
So like knowing that, you know, you have one function that produces, like, you know, a pair where like the car is an A list and cdr is like a normal list of integers or something, and it has another function that kind of destructures that and does some computation, just like as a random thing. So like you know that the function should, like, basically from the user's point of view, there are certain kind of data types that are potentially opaque that it would only need to facilitate coordination among several functions. Does that make sense? And those are I think the kinds of things that I spend a lot of my so basically the context here that maybe makes it clear is that I've, you know, been trying to kind of, in the spirit of this kind of stuff, try to think about, well, what is it that I really do spend a lot of time on when I'm programming that I think might be amenable to some kind of automated assistance. And one of the things is like kind of designing the right data representation, right? Where I have, you know, I can have a list of pairs, I can have a pair of lists, I can have a, you know, all kinds of different ways to set up this data that make my future computations on it easier or harder. And those are not necessarily things that like a user, you know, who needs this library to do certain things really cares about, right? Like maybe, you know, I feed it a bit stream represents like telnet, and it produces like a data structure and gives me a bunch of accessors to get properties of the stream, right? Like metadata about it. The user doesn't really care what that structure is. It just cares that it possesses the information in such a way that the other functions can read it and do what the user cares about. And so like thinking about synthesis in a slightly broader context, but not even very much, where it's like, instead of synthesizing one function given inputs and outputs, synthesize several functions and their coordinated representations given kind of inputs and outputs of that whole module or something like that. Does that make sense?
Or I guess another thing sort of in that vein is, what if I gave you, you know, three functions that work together, but I want to change the representation? Maybe you already have the code for it, right? And you're like, okay, I only want to rethink the representation. So now, you know, we're sort of making the code representation independent and switching that. And some of that you could do with program transformations, but some of it might require some degree of synthesis.
Right.
Yeah, so you could, I hadn't really thought of it that way either. You could have like sort of vertical slices of, hey, all of the code is there except for, I don't know what's going to happen with this variable. You know, how do you treat that input, or how do you decompose it, or whatever? Or I guess maybe you just have it representation independent, and then you're like, okay, I want to resynthesize these accessor methods and constructor methods to have this other property, or something like that. So maybe you do synthesis at the level of like the individual implementations. You know, this happens with environments and interpreters, where like maybe you want to use an association list, maybe you want to use a functional representation, or a hash table, or whatever it is, right? And so you want to be able to switch between those. And maybe you want to say, hey, I want a hash table, like go ahead and like synthesize the rest of the code from that.
Right. Like, I don't, and you know, it kind of, at the one, it seems like it's, you know, on the one hand, very much, you know, in a very, very similar type of problem to the kind of the way that we've been formulating the function synthesis stuff. And it's also like very much where I feel like I spend a lot of my time, like, you know, figuring out what some representation and discovering that, oh, now I need to do a computation that just is a horrible representation, and going back and redesigning that and having to change the other things. And like, I feel like that's kind of like a good chunk of like the thought that goes into my programming that probably doesn't necessarily have to, you know, is very amenable to something just like figuring it out, because they're just not, particularly with like data structures, like, you know, there's not necessarily like, you know, recursive computation that it has to do. It's potentially kind of a simpler pattern language one can imagine.
The other thing there is that sometimes sometimes there are program transformations that can get you part of the way, like defunction. Oh, sorry, yeah. So like if you make your code representation independent with respect to some argument or some thing like the environment being passed around, you can do at least part of that automatically, but you also probably need to ask the human questions in some cases. And depending on the representation you pick, you may be able to do everything through program transformations, or you might have to do some synthesis or more complicated stuff. So, trying to figure out the interaction between those things as well. Like, what would a tool like Barliman look like if you also had program transformations like CPS, right? So you can do CPS things, right, just fine. And also, could you CPS, this partially instantiated code with holes in it? Maybe you have multiple views of the same thing. Like here's the original direct style, and then here's like the CPS version, or maybe there are probably many versions of the CPS version at that point because of the holes. And as you're like filling in more of the direct style, like a whole bunch of the choices are being pruned. But maybe you can do some sort of like bidirectional thing where, you know something about what the CPS code should look like, so you could do some editing over there, and that feeds back in the direct style. And I think there are all sorts of interesting things you could explore. There's also this group in Europe that's done synthesis on data structures using types and Prolog, where it's like, data structure access, where it's like, hey, you have some really messy nested data structures, and you want to access this element. How could you synthesize the access pattern to grab that element?
Right.
That should be sort of automatic, right? And so we could probably do something similar as well. It's like, hey, I have this like nested list of vectors, of records, of hash tables, of whatever, and I want to get this element. Tell me what, just synthesize the accessor that would give me that.
Right. Yeah, and that's definitely the kind of thing that should be very amenable to the synthesis stuff. You say, okay, well, I know that this, eigen, whatever you call it, that the kind of elements the gen sims, the whatever your kind of things you pass in that just have to be themselves when they come out, and they can't be invented by the computer. It's like, oh, well, I know it goes into this method, which gives me something, and that something goes into this method, and it comes back out. So what had to happen in between?
Yeah. Well, all right. Well, that's plenty to think about.
I should say.
It's 4:00. I said Dimitri joined. Hello, Dimitri. My suggestion is, unless we have anything else we want to talk about, we stop the broadcast, and if we want to chat, and I'm curious to see what Dimitri is up to, then we can talk a little bit, and then I can get some pizza.
Well,
Hey.
Pizza sounds very tasty.
Yeah, it does. Is there anything you want to talk about on camera, Dimitri, or should I stop the broadcast?
No, not really, no.
Okay, so let me stop the broadcast. All right. Thanks, everyone, and hopefully you enjoyed this discussion, the demo of the debugger and where that might go, and also this talk about where we might go for future interfaces for an IDE like Barliman. See you next week. Bye.